I'm your teacher, Joseph Opati. Today we're going to cover a Form 4 topic called calculus. Now, before covering it, we have to review a Form 2 and a Form 3 topic which is related to it. That will be gradient Form 2 and Form 3 graphical methods, the part of rate of change. So let me just have the topic written there. So calculus is a Form 4 topic that actually is covered in 3 topics, that is differentiation, integration, and area approximation. But you're saying for us to understand this topic well, we need to be able to review some Form 2 and Form 3. Brief, of course, recap of what you covered in your Form 2 under gradient and equation of a straight line. So we have gradient. So gradient was defined as the measure of the steepness of a slope. Now, gradient was determined, if you remember very well, your Form 2 work, using the formula change in y over change in x. So the letter m here represents the gradient. Then we have delta y over delta x to imply what? To represent the change in y over change in x. Now, okay. Yeah? Okay, so change in y over change in x. Now, to get any change, you must have what? Some true values. So this topic, this formula here can be extended now to y1 minus y2 minus y1 over x2 minus x1. So the key things in this formula here are the following. Number one, gradient is change in y over change in x and not change in x over change in y. So a number of students normally confuse that and they interchange this and they have what? Their gradient as change in x over change in y, which is a mistake. Gradient is what? Change in y over change in x. Then what do we have here? We have y2 minus y1 over x2 minus x1, implying if at all I begin here with y2, I should maintain that consistency on the denominator here. I should begin with what? x2. But if at all I began with y1 in the numerator, I should begin with what? x1 in the what? Denominator. We want to give an example based on how we can apply this formula. Now, for example, you get a question in the exam. Find the gradient of a line joining points A, which has the coordinates 2, 1, and point B, which has the coordinate, let's say 4, 7. Now, you must recall that from your Form 1 topic, coordinates and graphs, a coordinate of a point takes the general form of x, y, meaning whenever you are given a gradient, the first value is the x value, the second value corresponding y value. So having known that and given points A and B and their coordinates and asked to find the gradient, we are saying this is what you do. We have point A and point B. So we have 2 points. I can label point A as point 1. I can label point B as point 2. So if at all point A is point 1, it means the value of x of point A becomes what? Our x1. The value of y of point A becomes our y1. Then, having labeled point B as point 2, it means the x value of B is what? x2. The y value of B is y2. So once you have identified your x1, y1, x2 and y2, to get the gradient, you can use either that or that. Now, let's begin by using this portion of the formula. What do we have? y2 minus y1. We have x2 minus x1. Therefore, the gradient of this line joining point A and B will be y2. In our case, y2 is 7. So we make our substitution 7. Then minus y1. y1 is given by, of course, 1. You subtract. Then over x2 given by 4 minus our x1 value given by, of course, 2. And then, of course, now you work out the numerator to give you 6. Work out the denominator to give you what? 2. The eventual value we get will be 3. Now, what if somebody decided to use this portion of the formula? So how should they go about it? We are saying maintain consistency. Here we began with what? y2. We had to begin with x2. So here, if at all I begin with my y1, which is given by, of course, 1, it means I'll have the 1, which is the y1, minus the 7, which is the y2. Then, having begun with y1 there, I should begin with what? x1 here. Now, the x1 value here is given by, of course, by 2. Then, the x2 value given by 4. Now, that workout will give us 1 minus 7 to give us what? Negative 6. Then 2 minus 4 to give us what? Negative 2. In the end, we end up with what? The same outcome as we got from the previous workout. So in summary, the key things about getting a gradient, we are saying it is change in y over change in x, and not change in x over change in y. Number 2, we are saying maintain consistency in the formula. You begin with y2 here, begin with x2. If you begin with y1, begin with x1. So having discussed that, we can look at a few more examples of doing what? Finding the gradient of a line, which I'm saying is a key thing to understanding the Form 4 topic, calculus, which now, after we have done with the basics, we shall go to. Now, a second, of course, now example. Given point T with the gradient of with the coordinates, of 4, 2, and another point Q with, of course, the coordinate of 5, 2. Now, in this case, how do we get the gradient and what will be the eventual value? We are saying here, we use what? Identify one of your points as point 1, meaning again, that is x1, that is what? y1. Identify our second point as point 2, meaning the x value there becomes what? X2, the y value becomes what? Y2. Now, how do you get the gradient? First of all, have the formula. It is change in y over change in x. How do you get change in y? We have to have some 2y value and find their difference. So I will have y2 minus y1 over x2 minus x1. Then our substitution, our y2 is given by 2. Our y1 also given by 2. Then we have our x2 value given by 5. Then, of course, x1 given by 4. In this case, we get 0 over 1. Now, you must know that 0 divided by any number, what do you get? You always get what? A 0. So don't forget that 0 divided by any number, you get what? A 0. So in this case, given point T 4,2 and Q 5,2, this becomes what? The eventual value of the gradient. Now we go to another example. Now, given other sets of points, let me call them points. Points, let's say E, with the coordinate 7, 4, and a point F with the coordinate 7, 2. So in this case, what will you get as your gradient? We are saying this, a similar steps like done in the previous question will be undertaken. So we are saying the gradient is change in y over change in x, still stressing that change in y over change in x and not change in x over change in y. Now, our point 1, our point 2. So we are saying that qualifies to be x1, that y1, our x2, our y2. Now, what will you have? We have the substitution of y2 and y1, giving us what? 2 minus 4 over substitution of our x2 and x1, giving us 7 minus 7. So we are saying 2 minus 4 will give us what? Negative 2. 7 minus 7 will give us 0. At this point, you must recall, as taught in your form 2, a number divided by 0, you get what? Infinite. So our answer is what? Infinite, which is normally written as what I call a sleeping 8. So we are saying 0 over number is 0. A number over 0 is infinite. Now, having discussed about or gone through the formula of getting the gradient and given the 3 examples I've given, another key thing you must remember is about the nature of gradient of a straight line. Normally there are 4. I'm going to discuss each one. So, nature of gradient. This is something you must be able to remember. Nature of what? Gradient of a straight line. Now the first point we're going to discuss here is the nature of the gradient of a line sloping downwards from left to right. This is the first thing we're going to discuss. Now, the moment you have such a line sloping downwards from left to right, so how will that gradient be? Now, a line with such an inclination will always have what? a negative gradient. So a line sloping downwards from left to right. So this is the y-axis, that is the what? X-axis. We just want to prove that whatever point I say is a valid point. I'm insisting a line with this inclination will always have what? A negative gradient. How can we prove that? Very simple. Let us pick some 2 points on the line. Let me call one point, point A, the other point, point B. Now, if at all I choose the x value of point A to be 1, it means the x value of B must be more than 1. Let me give it a value of 2. If at all I choose the y value of B to be 1, it means the y value of A must be more than 1. Because for the y value, they increase going upwards. So let me call that what? A point 2 in terms of what? The y value of point A. Now, having done that, it means point A in the end has the coordinate 1, 2. Now, it also means point B in the end has the coordinate 2, 1. Now, if at all those are our coordinates, we will just want to prove that a line of this inclination will have what? A negative gradient. Now, that becomes my point 1, meaning I've got x1, y1. My point 2, I've got x2, y2. So what becomes of the gradient? Gradient is change in y over change in x. Change in y given by 2 minus 1, which will be that. Change in x given by 1 minus 2. Now, what do we get at the end? We get 1 from the numerator, we get negative 1. Overall, we have what? Negative 1 as our gradient, proving the point I just gave early, that any line with this inclination, meaning what? Sloping downwards from left to right will have what? A negative gradient. Now, people doing business studies, you will remember what? Demand and supply curve. Demand has what? A negative, of course, now gradient. So any line with that inclination will always have what? A negative gradient. That's the first what? The first nature of the gradient of a straight line. We discuss nature number 2, which will be actually the reverse of this. A line with a positive gradient. Now, which kind of line is that? A line with a positive gradient will have this inclination. We are saying we have what? The line sloping downwards from right to left. Any line with this inclination will always have what? Will always have a positive gradient. And it's something, of course, we want to prove. Again, like in the other case, recall this is my y-axis, that's my x-axis. Now, I will choose 2 points. We have point A, we have what? Point B. Now, in terms of the x value, point A has what? A value of 1. It implies point 2 will have what? A value more than 1, which we can say, we can choose an example of 2. In terms of the x value, y value, sorry, if I choose point A to have a y value of 1, we are saying point B should have a value which is more than 1. Now, to simplify our calculation, let me just choose what? 2. Now, from that diagram, we see that point A has the coordinate, has the coordinate 1, 1. Point B has the coordinate 2, 2. Now, if I use those 2 points to find the gradient of the line joining point A and B, what will be the outcome? This will be the outcome. I will have change in y being given by 2 minus 1, then change in x being given by 2 minus 1 also. So what do we get? 1 over 1, which is 1. Of course, remember, we are interested in terms of what? The value which the gradient assumes. Our gradient here is positive. A point we said earlier that any line with that inclination will always have what? A positive gradient. That is nature number 2 of the gradient of a straight line. We go to the third nature, which now will be, of course, now talking about the issue of a line which is horizontal. Now, this is the line. Let me have the diagram. We have the y-axis here. We have the x-axis. Now, we have a line which is horizontal, meaning parallel to the what? X-axis. Now, this line here, if you're very keen, throughout will have what? A constant value of y. Let me give it a value of what? 4. But in terms of the x value, the value will be changing from point to point. I'm going to choose some 2 points. Label one as A, label one as B. Now, in terms of point A, if at all I assign it an x value of 2. Now, the value of x of point B should be something greater than 2. Let me give it, let's say, a value of 6. Now, from our diagram, it means point A will have what? A coordinate of 2, 4. Our point B will have a coordinate of 6, 4. Now, we want to find what? The gradient, just to prove the nature of this, of course, now, gradient of such a line. If you're very keen, change in y will give me what? Will give me a numerical value of 0. Change in x will give me numerical value of 4 or negative 4, depending on which side you begin with. Now, in the end, we said we get what? 0 over 4. We said 0 divided by a number, you always get what? A 0. Therefore, we get what? 0 here. It means a line with this inclination, meaning what? A horizontal line will always have what? A gradient which is what? 0. Okay, that is our third nature. Let me just quickly mention the fourth nature, then I'll give a summary in terms of what? The points we've just mentioned, and of course using diagrams. So we go to what? The fourth nature of the gradient of a line. Now, this will be in regard to a line which is vertical, meaning parallel to the what? Y-axis. So I have my y-axis there, my x-axis there. This is a vertical line. If you're very keen, such a line throughout will maintain the same value of x. But in terms of y, the value will be changing. Let me choose an x value of what? 4. And then choose some 2 points. I've got point A and I've got what? A point B. Now, point A, I'm going to assign a y value of 2. Having done that, very obvious, it means what? The y value of B should be more than 2. Let me give it again a value of what? 6. So, looking at our diagram, it implies the coordinate of point A is given by 4, 2. it also implies the coordinate of our point B is given by, of course, 4, 6. Then we find the gradient. Gradient is always change in y over change in x. Let me begin with point B as, let's say, point 2. I'll have 6 minus 2 to give me what? The change in y. I will have 4 minus 4 to give me the change in, of course, in x. In the end, I have 4 over 0. We said a number over 0, you get what? Infinite. Okay, we are done. So I've mentioned what? 4 key nature which the gradient of a line can assume. And I want to give a summary of that quickly. Of course, now using diagrams. Now, so you're saying we have 4 key, of course, nature which the gradient of a straight line can assume. Number 1, we are saying a line with that inclination will always will always have what? A positive gradient, meaning our change in y over change in x will be less than 0 because it is negative. We go to the second nature we discussed in terms of the summary now. Of course, we have the y-axis and we have what? The x-axis. We are saying if a line has this inclination, the outcome will be the line will have what? A positive gradient, meaning the change in y over change in x will be, of course, greater than 0, implying it is positive. Then we go to the third nature, which is in regard to what? A horizontal line. So having the y and the x-axis and a line which is horizontal, we are saying here the change in y over change in x will always be equal to what? 0. Lastly, talking about our fourth nature of, which a gradient of a line can assume is in regard to what? A vertical line. A vertical line, we have seen that will have what? A gradient which is undefined or infinite. So if you are very keen, I've been giving them in relation to what? The value 0. So a line with this inclination will have what? A gradient which is of course less than 0, implying negative gradient. A line with that inclination will have what? A positive gradient, of course, now, meaning greater than 0. A horizontal line will have a gradient which is equal to 0. Then a line which is vertical will have a gradient which is what? Infinite or undefined. Now, having done that, we can quickly go to other aspects of the gradient and equation of a straight line. Of course, still in Form 2, then once we play the Form 2 recap, we can go to what? A bit of Form 3, then introduce what? Our topic, calculus. So we go to the issue of the equation of a straight line. Okay, now equation of a straight line takes the general form of y is equal to mx plus c, where if you're very keen, you are taught m, its significance is that m is the gradient and c is the y-intercept. If you're very keen, you're saying from your graphical methods concept, you're told that m and c are constants, y and x are variables. But you're saying m is the gradient and c is the y-intercept. Now, this is the general form. But apart from this, we have other forms which the equation of a line can assume. Now, I want to give those forms quickly. The first form is this. Equation of a line can assume the form of ax plus by is equal to c. We have another form also here. We have ax plus by plus c is equal to 0. And lastly, the form which has other significance, we are going to discuss later, a form of 1 over ax plus 1 over by is equal to 1. And this form normally is called the double intercept form. But I'm insisting this is the main form of doing what? Which an equation of a line can assume. But also we are saying in various questions in the exam, the other forms can also be, of course, tested. So having discussed that, we want to discuss the key things, key requirement of finding what? Equation of a line. For you to get equation of a line, you must have, number one, the gradient. Number two, you must have at least a full coordinate of a point where the line passes through. So of course now, I'll give a general question, maybe which requires that form. Then I will give a question which, of course now, we're going to transform the equation into the other forms. So given a line with a gradient of 4 and the line passing through a point 3, 4, how can you get the gradient? So you're saying already here we have the key requirement which will enable us to do what? Get the equation of a line. We have the gradient, we have what? A point where the line passes through. So we have the following two approaches which can be used. So method one of finding the equation of a line. We have the gradient 4, we have what? The point 3, 4. This will be the approach. I'm going to consider the gradient 4. I'm going to consider 3, 4, which is a point where the line passes through. And then I'm going to have an introduction of a point xy. Then connect this, that, and that in an equation. Now recall that to get the gradient, we do what? Divide change in y by the change in x. The change in y in this case will be given by y minus 4. Of course, we have y minus 4 there. Then the change in x minus 3. And then equate this to what? The gradient, which is 4, which can be written as 4 over 1. Now, in the end, what do you get? Let's just have this cleared to have a space to clear that. You proceed by cross multiplication. So I will have this by that, then this by that. What do you get? We have 1 into y minus 4 is equal to 4 into x minus 3. So y minus, 1 times this will give you y. 1 by 4 gives you, of course, that we end up with y minus 4 equals to 4x minus 12. Then, of course, we want to give it in the general form of y is equal to mx plus c. It means I'll have y equals to 4x minus 12. That element of negative 4 crossing to the other side to become a plus. Then we have y is equal to 4x. Negative 12 plus 4 gives you negative 8. So we are saying we have our equation in the general form of y is equal to 4x. Y is equal to mx plus c. Now which is what? Y equals to 4x minus 8. Now we want to see how you can be able to give your equation in the other forms. Of course, now if at all it becomes a requirement in a given exam question. So what I'm going to do, I'm going to give, of course, now different values for the gradient and, of course, a point where a given line passes through. Let me use gradient of 5/2 and a point 3, 2. So given the gradient of 5/2 and a point 3, 2, how can you find the gradient of the line in different forms? So we discussed the first form, which is the general form, y is equal to mx plus c. Then of course we shall proceed to the other forms. So my focus at the moment is in the form y is equal to mx plus c. So what do you do in this case? Number one, consider your gradient with the value 4/2. Consider the point 3, 2 and introduce a point xy. Then connect them, of course, in an equation. So we have y minus 2 giving us the change in y, x minus 3 giving us the change in x. Of course, that is equated to 5/2. How do we proceed? In the similar manner we did in the other question, cross multiply. What shall we have? We shall have 2 into y minus 2. Then we have that equated to 5 into x minus 3. Then we open the brackets, we have 2y minus 4 equals to 5x minus 15. Then we have the 4, which is negative, becoming a positive in the other side. So we have 5x minus 15 plus 4. Then in the end, what do we have? 2y equals to 5x minus 11. You divide through by 2. Divide through by 2. Why? We want to achieve or obtain our equation in that form. So you must recall, for the equation to be this form, we have some 2 key conditions. Number one, the variable y must be left on one side on its own. Number two, its coefficient must be 1. So at this level, we are saying the coefficient of y is 2. So how do I make it 1? Divide through by 2. So what do you end up with? You end up with y equals 5/2x minus 11/2. So now we have our equation in the general form of y is equal to mx plus c. Now, we are going now to take this equation and transform it, assuming now in a given question, other forms of the equations are required, apart from what? The general form of y is equal to mx plus c. So which is the form number 2? The form number 2 is ax squared, form number 2, ax squared plus bx plus c is equal to 0. In most cases, they would suggest that a, b, and c are integers, meaning a, b, and c are whole numbers. So we just, having found the equation in this form, we just modify it. So what is the condition here? The condition are 2. Number 1, every variable is on one side. Then your a, b, and c should be integers, meaning we should not have fractions in our question. So what do? We just take our equation y is equal to 5 over 2x minus 11 over 2. The first task here would be to do away with the fraction. So LCM of this and that, of course, is 2. So multiply throughout. Multiply everything by 2. So that by 2, that by 2. Now what do we end up with? We shall end up with 2 times y, you get 2y. 2 by this, you get 5x. 2 by this, you get 11. So we've only taken care of one condition that was, of course, now given. In that, we have done away with the what? Fraction. But we have a second condition. We are saying all the variables and the constant must be on one side. So how do you achieve that? Just take your 5x and the constant negative 11 on this other side. If possible, it should be actually ax plus by, sorry. We should have had here ax plus by, not bx. So we shall have 2y minus 5x plus 11 is equal to 0. So we have now our equation in that format. Of course, now we have taken care of the what? The two conditions which were given. In that number 1, we were told a, b, and c should be integers. Now, of course, integers means what? They should be whole numbers. We have taken care of that. And then we are saying the variables and the constant should be on one side. That one now has been achieved. Now, this becomes our final answer. Okay. Okay. So we have discussed two forms in which the equation of a line can take. Now we go to the third form. The third form, of course, is the form of ax plus by is equal to c. Now, here we have, of course, now in most cases, the condition can be a, b, and c are integers. Now, having been given that condition, it means now we shall have two conditions. Number 1, ensure a, b, and c are whole numbers. Then it means now the constant will be on one side on its own. So we are saying the gradient was 5 over 2, the point was 3 over 2. So what shall we have? Y minus, of course, 2 over x minus 3 is equal to what? 5 over 2. Then this will be 2 by that, what do you get? 2y minus 4 equals to 5x minus 15. Then we shall have 2y, taking this constant, the other side is equal to 5x minus 15 plus 4. So we are here, 2y is equal to 5x minus 11. But remember the condition, the constant must be on one side, on its own. So, and based on this arrangement, I should begin with what? The variable x. So this will cross to come to negative 5x plus 2y is equal to negative 11. Now, do you leave your answer like that? Now, that will not be okay. Now, having been told to begin with the ax, just ensure that this is positive. How do I achieve that? Multiply throughout by, of course, negative 1. This will give you what? 5x minus 2y is equal to 11. So now we are saying in that form, that final answer would be okay, the form of ax plus by plus, is equal to c. So we have discussed three forms so far. The general form of y is equal to mx plus c. Number 2, ax plus by plus c is 0. And number 3, ax plus by is equal to c. And lastly, we go to the form we call what? Double intercept form. That is the form of 1 over ax plus 1 over by, of course, is equal to 1. Now, I'm just going to take the equation which we had, which we have just found, using the given gradient and that given point, and modify it, of course, now to assume this form. Recall, for this form, the conditions are two. Number 1, the variable x and y must be on one side. The constants must be on the other side. And then you make sure you achieve this. The constant must be made to be 1. So we're just going to take what? The equation we formed here and modify it. So what do we have? We have 5x minus 2y is equal to 11. So already the variable x and y are on one side, the constant on the other side. Now, how do you eventually achieve, of course, now in obtaining this equation in that form? Make sure your constant here is 1. So what do you do? How do you achieve that? You divide through by what you have there as your constant. In this case, what do we have? We have 11. So divide through by what? By 11. Divide through by 11. So we have 5 over 11x minus 2 over 11y is equal to 1. So we have our equation finally in the double intercept form. Of course, we are done with that. Then we have to proceed now to our next part and discuss the issue of the y and x intercept. So y and x intercept. Of course, we're just doing a recap of the Form 2 topic, gradient and equation of a straight line, which now will form the foundation of the Form 4 topic, of course, calculus. Now, x and y intercept. Let's quickly discuss that. So I'll begin with what? Y. Let me just have both x and y intercept. So let me have the diagram which I'm going to use to actually explain that concept. Given a straight line, we have the y-axis, we have the x-axis. We are having the line, of course, touching the y-axis at that point, which I'll call C, and touching the x-axis at this point, which I'll call point B. We are saying the y-intercept is a point where a given line cuts the y-axis. The x-intercept, on the other hand, is a point on the Cartesian plane where a given line cuts the x-axis. Of course, in regard to this diagram here, we are saying point C is the y-intercept. Our point B is the x-intercept. If you're very keen in terms of the coordinate of point B and C, the following thing should be, key point should be recalled. We said where a given line cuts the y-axis, the corresponding value of x will always be 0. Now let me call this, let's say, a point 4. This implies the coordinate of point C will be what? 0, 4. Now, on the other hand, where a given line cuts x-axis, or basically at the x-axis, this is a fact that always the corresponding y value of any point on the x-axis would always be 0. So that if at all this was again a point 4, it means what? The coordinate of point B will be given by 4, 0. So again, a quick summary. We have said y-intercept is a point where a given line cuts the y-axis. Sorry, x-intercept is a point where a given line cuts what? The x-axis. And we have said the key thing about those 2 points is that the y-intercept is a point found on the y-axis. Any point found on the y-axis has a corresponding value of x to be what? 0. Now, the x-intercept is a point found on the x-axis. Any point on the x-axis will have its corresponding y value being what? Being 0. Now, having said that, we want to look at examples of questions which might require, of course, now application of this concept. Now, you are given a line with the equation y is equal to 2x plus 4. And then you are required to get the x and the y intercept. Now, what do? I'll begin with what? The y-intercept. Now, to get the y-intercept, you can use the following 2 approaches. Method 1 of finding what? The y-intercept. Just make sure you have your equation in the form y is equal to mx plus c. Now, I said this, this form dictates that you have observed 2 conditions. Number 1, the y variable is on its own on one side. Now, the x variable and the constant is on its own again on the other side. Number 2, ensure the coefficient of the y variable is 1. If you're very keen, our equation already has assumed that particular format. So given a line in this form, we said significance of m is that m is the what? The gradient. Significance of c is the what? Y-intercept. So for our case, our y-intercept is what? Is 4. So remember, How do they define the y-intercept? Y-intercept is a point where a given line cuts the y-axis. So I think given such a question whereby we were given the equation and we were supposed to find what? The y-intercept. It will be now a mistake to say the y-intercept is equal to 4. Why are we saying that? From the definition of the y-intercept, we are saying y-intercept is a point, and a point must have what? Two coordinates, the x and the corresponding what? Y value. Now, the 4 we have just, of course, now obtained here is only what? The y value. So given the requirement that you are supposed to find the y-intercept, we are saying give it as a what? Full coordinate. The argument was at the y-intercept, the corresponding value of x is 0. So my answer will be 0, 4. That is the what? The y-intercept. That is method 1. We just said have your equation in the form y is equal to ms plus c, and c becomes what? The y-intercept. In the end, give the full coordinate. What about the second approach, method 2? What do you do? For method 2, we are saying this is what you do. The argument was at y-intercept, corresponding value of x is 0. So we are saying our x here should be 0. You make your substitution and, of course, solve for what? Solve for y. So this by this will be 0. You get your y as what? 4. Eventually, you give your answer, of course, in terms of a full coordinate. So we have y-intercept using our first approach. We have the same using what? The second approach. Now, the question is, how can you get the x-intercept? If you're very keen, a similar approach will be used, but now in the reverse form. The argument here was at y-intercept, x is 0. Now, to get x-intercept, we shall use what? The reverse argument that at the x-intercept, the value of y is 0. So, how do you get that? We have our equation. We have our equation given by that. Of course, the equation is already there. So we just take what? Put 0 where we have what? Where we have y. Then solve for x. Now, the variable 2x here will cross to become negative on this side, and then divide through by what? By negative 2. What do you get? Negative 2. But I'm insisting, what was the definition? X-intercept is a point where a given line touches what? The x, cuts the x-axis. A point implying what? It must have two coordinates. So eventual answer should be not negative 2 but negative 2, 0. You give it in terms of what? A full coordinate. So having said that, we have we have an easy approach which now can give you x and y intercept simultaneously. Something we want to go through. Remember, this was the line which you were given, and then we were required to get what? The x-intercept and the y-intercept. We found our y-intercept. Remember that? To be what? To be 0, 4. And we have found our x-intercept to be, of course, negative 2, 0. So we want to see how we can quickly achieve that, of course, now simultaneously without doing them separately. Now remember, we are saying this is the significance of talking about in regard to the double intercept form. We said that form of the equation of a line has a significance, and of course at this point I'm going to clearly outline it. So given equation of a line in the form 1 over ax plus 1 over by is equal to 1. Now we call this what? Double intercept form. Now remember, our line had the equation y is equal to what? 2x plus 4. And this is what we obtain as the y-intercept, and this as the x-intercept. Now we want to see how we can use this to obtain both, of course, simultaneously. This is what will happen. We shall have our equation in this form. The conditions are two. Number one, have the variable x and y on one side, have the constant on the other side. So what shall we have here? We shall have our line modified, of course, in this manner. This will cross to become what? Negative 2x plus y is equal to what? Is equal to 4. Then I make sure whatever constant I have there is 1. So divide through by what? By 4. Divide through by 4. Divide through by 4. Now what do we get? We get that simplification to be negative a half x. Then plus a quarter y is equal to 1. Now, having done that, how do we eventually obtain that and that value using this approach? Very simple. So given the equation in this format here, we are saying the x-intercept will be reciprocal of coefficient of x, which at the moment is 1 over a. What shall we have? A over 1. And then the y-intercept will be reciprocal of the coefficient of y, which will be b over 1. Now, in our case, what shall we have here? We have the variable x here. The coefficient at the moment is negative a half, meaning x-intercept will be reciprocal of this given by negative 2 over 1, which is just what? Negative 2. Then our y-intercept will be reciprocal of the what? Coefficient of y, which at the moment is a quarter, becomes what? 4 over 1, which is what? Of course 4. If you are keen, these are the same outcomes we obtain, negative 2 and 4. Of course using what? The other approach. But I'm saying in the end, can you just play safe and do what? Give your answer in as a full coordinate. So we had 0, 4 and negative, of course, 2, 4. I mean negative 2, 0 and 0, 4. Those are what? Our x and y intercept. Now remember, we've not begun our calculus. We're still doing what? The recap of the Form 2 topic, gradient and equation of a straight line. So in regard to what I've just mentioned, we want to see a question which can come, of course, now from that particular area. Now look at this question. Question is, find the equation of a line whose x-intercept is 4 and y-intercept is, let's say, -3. So given such a question, how can we approach it? Of course, we've got several methods. There are two actually. Method one, this is how you'd argue. This is the x-intercept. At x-intercept, corresponding value of y is 0, meaning the full coordinate of that point will be 4, 0. You've been given the y-intercept as -3, meaning the full coordinate of that point will be actually 0, -3. Now, having those points, how do you proceed next? You proceed by finding what? The gradient. We have change in y. If you're very keen, change in y will be 0 minus -3 to give us 0 plus 3. Then change in x, 4 minus 0. We have what? 3/4. Then, having found the gradient, remember, this is what? General form of the equation of a straight line, where m is the gradient. So we have y is equal to what? 3/4x plus c. C is our y-intercept, which in this case is what? -3. So that becomes our eventual answer.